When we make estimates about a population, we are always prone to errors. So, an important statistic that results from the central limit theorem is the standard error of sample mean, which is defined as the standard deviation of the sample mean and equals the population standard deviation divided by the square root of the sample size n, when the population standard deviation sigma is known. However, when the population standard deviation is unknown, the sample standard deviation s is used instead of the population standard deviation, and the standard error is defined as the sample standard deviation divided by the square root of n. Remember that the sample variance is calculated by adding the squares of the differences between the observed values and the mean, divided by the sample size n-1. Let's take an example. Suppose that the mean sales for a sample of 35 pharmaceutical businesses is $15.70 million, and the variance of the population is $12.25 million. What is the standard error of sample mean? Since the population variance is known, we use the formula with sigma. We divide the portfolio standard deviation by the square root of the sample size. Here, carefully note that $12.25 million represents the variance. So, we need to take its positive square root, which is equal to 3.5. Then, we divide 3.5 by the square root of 35. And we get a standard error of $0.6 million. So, what then does this tell us? Based on the central limit theorem, the distribution of sample means would have a mean of $15.70 million, which is equal to the population mean, and a standard deviation of $0.6 million. Let us consider another example. Suppose that the mean of the last 40 weekly returns of a stock is 4.6% and the sample standard deviation s is 35%. What is the standard error of the sample mean? Since the population variance is not known, use now the second formula. We divide 35%, which is the standard deviation, by the square root of 40, the sample size, which gives 5.5%. Now if the sample size increased from 40 to 250 with the same mean, the standard error of the sample mean becomes 35% divided by the square root of 250, which gives 2.2%. Notice here that as n increases, the standard error decreases. Find the full central limit theorem and mean estimates video on www.cognivisio.com.